Hello.
Hello. Hi.
Hi. Hi. Can you hear me?
Yeah, I can hear you. Thanks for coming. This is my first time on the platform, so
Oh, okay. That sounds decent. That sounds decent. But yeah, thanks for trying this platform out. So this is gonna be like a practice interview. So without like disclosing too much about ourselves, can you like quickly introduce yourself?
yeah, I'm a new grad. I'm looking for work. Sorry. Am I supposed to talk as an I
Yeah,
am an
sure, sure.
interviewer, or I have to introduce myself to you because I wouldn't say I'm looking for work, but yeah, I'm a new grad. I'm looking for positions with regards to new grad front end or back end or full stack positions. Um, I've I'm going to be graduating in about 4 months, but I am interviewing just preemptively, so I'd like to have a position, after I finish school. Um, and yeah,
Sure. Yeah, that sounds like a decent introduction. So just a quick intro about me. I'm like a mid-level engineer at Google, right?
oh, that's really great.
So
Yeah.
yeah, I'm like this is my third or fourth interview on this platform, so I'm kind of new as well. So my main programming languages have been Java and Python. So if
Okay.
you're familiar with them, we can probably start the question. But if not, if you want to choose C++ or some JavaScript or
Uh,
things like that, that's also fine with me.
yep. I've been practicing the most in Python, so I think I'll go with Python 3.
Okay, sure. Let's switch to that. Okay. Here we go. So let's get started with the question. Usually the question starts for like the question is asked for 45 minutes, but let's give the same amount of time here, and then
Okay.
at the end we can probably debrief saying that what went well and what didn't go well and things like that, right?
Okay. Thank you.
Let me paste the question. Okay. So, give me one second. Right? So basically, your task is an array is given to you. Okay, your task is to
Okay.
split the array into k subarrays, right?
Okay.
Such that the maximum sum of all subarrays is minimum, right?
Minimum. Okay.
So say for
Yeah.
example, yeah, go for it.
Oh, sorry. No, I just, yep. No, wow. So let me just clarify what minimum is, and I guess I'll look at this test case. One, two, three, four, and so they give you K, and you have to split them in a way so that you don't have like you have a minimum combination of them. I see. Uh, I see. So in this example, they give you one, two, three, and four. K is 3, and yeah, you want to put the 1 and the 2 together, and the maximum sum of all subarrays, okay, is 4.
hmm hmm
Whew, okay.
Yeah, this is a pretty challenging question, right? So take
Yep.
your time. That's what I would say. So
Yep. Okay.
usually a Google interview question in on-sites are usually in this level, right?
Okay, that's
So
yeah,
yeah, go for it.
gotta practice. Gotta practice. Thank you though. I So let's just think of like maybe I'm gonna think of a solution that might be super slow, but it would maybe work. How I would do it if I had I had to divide into three subarrays. What I would try every combination that could give me three subarrays. Maybe I would try 1 and 2, and then I would try I would try maybe building the biggest subarray possible, and then so I know if I have 4 elements in my array and I can only build three, then I just build my first subarray as big as possible, 1 and 2, and then I try three, and then I try four, and then I would do 1, 3, 1, 4, and and my subarrays being those individual elements that are left, I would keep going, and I just keep track of my minimum possible values, and if I try every combination, I'd have something at the very end. Now, to look at this time complexity, or look how fast this runs. Let me just think about how fast or how slow this would run. How many subarrays am I actually building here? I would go through. So in my first example, I have one. My first subarray will be 1 and 2. Maybe I'm talking, but I think it's also okay to just talk about to type it out too, just for clarity.
Sure. Go for it.
Yeah. So that that would be a first run, and then it would be 1 and 3. Sorry, 3.
Hold on, Bri, 1 second. 1 and 3 is not a subarray, right? 1 and 3 is like picking, like the subarray needs to be contiguous, right? So it should either be 1, 2, 3, 4, or 1, 2, 3, 4. Okay, like that. So it should be contiguous.
Yeah, my apologies. I should have clarified that as well. So I guess it would end up being my next test would probably be doing once I realize my first subarray is length 2, I would try a first subarray of length 1, and I would have my second array be the maximum possible, and then so on and so forth. Just for this, well, honestly, in this case, there are, if I'm not mistaken, there are only. Wait, let me just write this out to myself. There might be only 3 subarrays, but let me just clarify.
Yep.
Yeah, there are only 3 subarrays. It would this particular case, it would only take one pass to try all of them. But I might be mistaken here. Let me just. It doesn't look like there. If it's contiguous, then it doesn't look like there's any other option. And I just want to make sure it's literally K. It's not like less or more than K. It's just always K. Okay, it's always K. But that is okay. Split the given K subarray, so they must color out the elements. Maximum or subarray sum achievement of minimum possible. Okay. Well, I'm going to, while I keep this example in my mind, I'm just going to think about the second case. I have 1, 1, and 2. There's only 2 ways to break it up, so I have contiguous subarrays. This and 1, 1, 2. Well, okay, this is, I guess I better separate these. This is only 2 subarrays. Now, these examples are reasonably small. If I had bigger test cases, I don't think I'd only use 1 pass, is what I'm kind of convincing myself. If K gets bigger, if the sample size is larger and K is larger, there just tends to be, if I'm going to guess, like many more sample cases. Yeah, so it would take not just 1 pass, but I'm trying to think of it. It would just take me more passes. I think I'll just remove this and give myself maybe slightly longer array, and I'm going to give myself maybe a different K value, just to maybe show myself how many passes it would take. So let's take this, and I take a K of 3, and my first, as I kind of said, I would start with the maximum possible. So this will be 4, and it'll leave me with 5, and it will leave me with 6. But that's the maximum possible. But in this case, you can see that I don't necessarily slide that first subarray downwards. I would have to try this next. I would have to try 4 and 5, and then I would have to try 5 and 6 before I'd even 4, and then 5 and 6 before I even start exhausting more cases. So
Yeah.
how long would this take me? Um, in if I let's call this it would be n to the well, let me just describe this to myself. It looks 4, 5, 6. For n times n to for big every big sub sub array, I would have to break it down until it's down to 1. It's would that mean it's I don't want to say it's n to the n, but
You can answer the time complexity in terms of k and n.
in terms of k and n, yeah.
Yeah.
Well, in terms of n to the, I'm just trying to talk to myself to think if it's n times k or um if
So yeah,
yeah.
think about it this way. Okay. Say for example, you have n elements, right? We need to make k subarrays out of them. Okay. How do we choose k minus 1 vertical, like splitting lines, such that between two vertical lines there is one subarray? Like imagine there is an array, you're like splitting the array by drawing vertical lines, right?
Okay. Yeah.
So
Okay.
right.
I I have a piece of paper on me, but there's a drawing window here, so I should do this.
Or else you can look at my example, right? So that just did this,
Oh, okay.
right?
Okay.
Right.
Okay.
So one for 1 2 3 4 5 6. Okay. One such configuration is here you draw a vertical line, okay, marking this array as the zeroth array, and then the next vertical line to first vertical line, okay, is your second array, and then the remaining is your third array, right?
Mhm.
So k minus 1 vertical lines uniquely determine a split of the main array, right?
Yes, a split of the main array. Um. Well, yeah. Drawing it like that, that's interesting for sure. I um k minus 1 split, and what's a good way to do that? Um.
Okay.
Okay. This split the given array. Sorry, one sec.
Mm-hmm.
So if I just want to see if I can just drop it one at a time and do a calculation, but I'm not sure that would uh, work. I'd like to build. Um.
Calm down, think. Calm down and think. Don't worry.
Yeah. Thank you. Um. Just to talk out loud, I'm just thinking. Give myself if I want to split them. I'm not sure if I would maybe add them all up and give myself a reference point to see what the maximum sum could be. Because I know a subarray would have something smaller than a maximum sum. Um, I'm not sure if that could help, but if I added all these up in this example,
Mm-hmm.
I would have 6 plus 4, 10 plus 21, and I'd know that my subarrays. Uh, not to say it can't be. It would be less than 7 per se. Sometimes they're like they are it's the array is unbalanced, so you might have some subarray like 20 plus 1 plus 0 or something. So I don't know if having some sum and dividing it accordingly would also work. I'm gonna discard that idea. I
So basically, you are thinking about some sort of an optimal way to solve this question, right?
I'm thinking of a way.
Okay. So can you think of like a brute force way? Like, can you construct all the possible subarrays, right? All the possible
Oh,
k subarrays, and then try to, find
oh,
the minimum
oh,
answer.
okay. Okay. So going back to my original, some of my cases I left down there,
Hmm.
I would, and I guess maybe speaking in the hint you gave for vertical bars, I guess I'd have two bars, or in this example, I would have two bars and I'd leave them at the end, and I'd shuffle the left bar and I'd shuffle the right bar until it met the left bar, and then I shuffle my left bar one to the left, and then I shuffle my right bar, and so on and so forth. And that's those are like in this case two bars as in two pointers, but
Mm-hmm.
two
Mm-hmm.
pointers to like shuffle that I keep moving left until I get back to the very start. Um, and then that's a way to generate subarrays, and it feels like it's dependent on how many bars there is. So if you just have one bar, it would move to the left. But
Yeah.
if you had more bars, your second bar would move, has to do a full, it has to move through the list until it met the first bar again. So the
Mm-hmm.
number of loops is dependent on
Okay.
k.
Yeah.
So that's um,
Mm-hmm. Okay. You're
that
on the
I
right track. Yeah, you're on the right track, but instead of taking the value k and iterating, like writing like a for loop k uh, times, like a k inner for loop, right? Instead of doing that, like, can you think about where can we place k minus one bars, right? How many positions can k minus one bars take?
oh it would be in this example, it would be k times k minus 1 over 2. Wait, actually, um, I yeah, okay. The first bar, the left bar, it could be in one, two, three, four, five, four different spots, and
Mm-hmm.
the right one could be in uh, one spot, one, and then one. It only has one option for one case, and then two options, and then three, and then four. So that's total of 10. Um,
Mm-hmm.
10 in this example.
Okay.
Um,
So basically what you are doing was out of n spots, okay, you're picking k minus 1 spots. So out of 0, 1, so on up to n minus 1, okay, you are picking k minus 1 numbers, right? So how many such ways are there to pick k minus 1 numbers from the list of 0 to n minus 1?
um, if I had 0 to n minus 1, picking k minus 1 numbers.
Mm-hmm.
Sorry, so you're saying, sorry, your question was how many ways I can pick k plus 1 numbers?
Yeah, k minus 1 numbers. How many ways can you pick k minus 1 numbers from the array 0 to n minus 1?
It would be n minus, um, so the first bar would be n minus 1 ways,
Mm-hmm.
um, and the so on and so forth would be n minus 2, n
Mm-hmm.
minus minus 3,
Mm-hmm.
and um, until 1. And so and it's based on k, so that's n.
Sure, some n minus k plus 1, right? Something like that.
Yeah, n minus k plus 1.
Yeah, so the last one would ideally be n minus k plus 1, right? That will be the total number of ways. Or
Right,
basically n choose k minus 1, right?
right. Oh, so okay, I see. And choose k minus 1.
Okay, so that is the total number of ways. Programmatically, how to figure out which are all the k minus 1 slots or k minus 1 numbers you can pick out of n minus 1 numbers. Do you know a way to do that?
No way to pick and sorry, your question. Can you repeat your question again?
Sure. Can you programmatically pick uh, k minus 1 uh, numbers from 0 to n minus 1 list, right? Such that all possibilities are covered.
I uh, I I think I could do that. But how would I? Okay,
Okay, I mean, uh, like one hint I can give, you can go from index 0, right? At index 0, you can pick the first vertical bar, or you can either pick the index 0 as the first vertical bar or not pick index 0 as the first vertical bar, right? And every time you pick it, you can decrement the value of k, okay, and then proceed to the next index, right?
so so you're saying put a bar at the very beginning and just
No, yeah,
sorry.
I'm basically saying start at the first index, okay? You can either put the bar in the first index, okay? Or you can choose not to put the first bar in the first index, right? There are two ways,
Right.
okay? So at,
You mean between the first index and the second index?
yeah, I mean, you
Oh,
can
okay.
consider it like that, okay?
Okay,
So
yeah.
you can pick either to place the bar between the index 0 and index 1, okay, or you can choose to place the first bar ahead of index 1, right? At every I index you can either pick to place the bar there or refuse to place the bar and then move ahead, right?
Right.
You have two choices, right?
Yeah,
So
you can
can
do
you
it or
pick?
you can not. Yeah.
Yeah, you can either do it there or you cannot do it there, right? So at every choice you can, like, can you like write a exponential function which says like if I placed it there, then I would decrease the number of bars to place and then recursively call the next index, right?
Decrease the number of bars to play and then recursively call the next index. But okay. But do you recursively call the subarray past that index or
Yes.
oh, that's what you're saying.
Yeah.
So you place a bar at an index and then you recursively call a subarray after that and then you place another bar. That was what you were describing?
Yep.
Um yeah, until you place all your bars. Um
Basically.
I could yeah, I could try that. Recursively place your bars. Yeah, just and then so yeah, you recursively call it all the arrays to the right, and then what's like left is what you have on the left. And then you hopefully, yeah. I don't know what to do once we come back from a recursive call, but at least I can place bars. Um,
Sure. At
yeah.
the very end of the recursive call, right? Once you have placed all the bars, you'll have an idea as to how much is the sum of each subarray, right? From that you can pick the maximum sum and then compare it with the global minimum.
Uh, yeah. I if I'm thinking of something recursively, I'd give myself a base case. If I had, let's say, okay, if I had no bars, that means I'm at the end of my array. I that means k is like equal to 1. I just clarifying that k 1. Yeah, k is bigger than 1, bigger or equal to 1, less than n. Okay, so base case is k is 1. I would just return the I would return the maximum. I return the sum of that array, and do I want to compare it to my global right away, or compare it to, or maybe I just return the sum. I just returned the sum. I think if that was my base case. Let me continue this. So it's just in this case, it's just a super basic case. I've returned 6, and that's my only case. If I had k this and k equal to 2, I guess I place a bar, so to speak, in between 1 and 2, or I could not do that. So I would recursively. So I would recurse on the first recursive call would be 2 and 3, and
k
I
equal to
would
1.
and k is equal to 1, returning 5. Now, what happens when I return 5 to my original? Maybe I'll put this in like a tab. What happens when I return my 5? I probably have to check my 1 as well and compare. Well, I have to at least compare 1 and 5. Maybe not on a list is not the best way to show it, but 1 and 5, and then I return the max of that. But then I have to check the other recursive call, which is the next option, which is just 3, and k is 1, and I return 3 here. And now I guess
1 plus 2 you're going to compare with 3. Yeah.
1 plus 2 is 3, and now I have. Well, I guess do I want to check? Do I want to put this in my? Do I want to add? Do I want to add 5 to my global now? I think that's really how add global.
Yeah.
Global 5, and then
you mean
it would be
min,
like
right?
My apologies. Yeah, global min, and it would just be max of global min and this local min. I don't know how to describe it. This local min.
Yep.
So this this looks like, and then I guess I have after at the end of all this, the answer would be 3. I apologize.
3. Yeah.
My answer would be 3. So this is interesting. This is admittedly the simplest test case I could give myself to just understand this. Now I just want to know. I'm just like talking to myself. Like I just want to know what happens if I had k is more than 2. Placing 1 bar is not that difficult. But what happens if I have more bars? Maybe if I use this 1, 2, 3, 4, for example, and my k is equal to 3. So I have to have multiple recursive calls. So I would have to, my first recursive call will put the bar there, and then k is equal to 2. And then I haven't reached the base case because my k is not 1 yet. So I'm going to try doing this. And then I'm just going to talk about calls for the moment. I think my next, this would be, k is equal to 3.
Yeah.
I put a bar, k is equal to 2. I put a bar, k is equal to 1, and this is fine. I'm gonna return sub array sum. So just 2, 3, 4. That means this one would be 4. This is something I would return. This one I would return as well, and then I would.
What is line 37? Why is it there? So.
Oh, sorry. I had 2, 3, and 4. So I put my first bar between 2 and 3, and then I put my second bar between 3 and 4.
Hold on. Didn't you place your first bar between 1 and 2?
I put this one here, and then for this one I put it here, and then I have to try putting it here.
Okay.
So
okay.
I would have like 4.
Case.
Yeah. My apologies. I don't know. This is just how my tabs are. And then I think those. And now how do I compare these ones? Oh, it's kind of like a. It's not. It's like actually, maybe I should write this out to myself. Return 7. Return 4. And here it would be 2. It's 7. And here would be 5 and 4. And that would give me, and then 7, 5, 5, and I would compare these ones, and then I send that back as my best option given the bar at this place. Now, how do I compare 7 and just with my variables? Oh, I'd honestly just maybe have like a local min. Yeah, it's really just as like a local minimum. And then I'd return 5, and then what I've discovered from this first bar is that best option is 5. Wait, yes. And then I keep, and then I basically, this k equals to 3, and then I basically move my bar forward, and then repeat the whole process again. And then until my bar is at the very end, until my bar is at the very end, and hopefully I'm keeping track of some stuff here, and then I'm just gonna and I keep track, and I return the minimum of these options given that the bar is in second index, bar is in third index, and so forth, and then I return min of all that, and then I return the minimum of all that. So, and I guess fundamentally that's what this approach would look like. How just clarifying if there are any other cases that like edge cases, for example. If let's see, we clarify k here, and k is less than n, and then so n has to be at least 1, and k has to be at least 1. Okay, so let's see, like if do I need to add at the very beginning that sometimes you don't have to, but if n like is equal to 1, maybe I just return this number because you can't place a bar. So you wouldn't do a recursive call. So I do need this base case somewhere earlier that just says that, like, just return I don't know, nums 0.
Sure, something like that, right?
Something like
So
that,
yeah. So now that you know the approach, can you like go ahead and start writing the code for this?
yeah. Yeah, I'm going to try doing that. Okay, here. Define. We'll just call it K-split for now until I find a better name. Okay, so and then it's an array of, okay, so we're just going to call them nums, or array, and, oh, it just highlighted it, so I thought it was, for some reason, okay, yeah, base case first.
Yeah, just FYI, ignore the compilation errors. Like most Google interviewers won't care.
Okay, that's cool. Thank you. Oops, sorry, I clicked on something on my side. Okay, never mind. Okay, length. If length is equal to 1, I return the array. And now, because I'm going to need some sort of second function, I'm not writing it fully out yet, but until I find a better name. Now, because my base case can't be my recursive function, so I'd want to, do I place a bar? No, do I place a bar right away and then call it? Do I do a for loop for my first bar and then call it every time, or do I try to simplify it and or do I try to simplify and put that all in my function? If I have my k is equal to, if I have my k is equal to 1, well, k is always at least equal to 1. So you're always going to put a bar in. So my n has to be 2 from here on in. So let's, maybe if I had, okay, if I had, sorry, oh, actually I need a k. They give us k. Yeah. So I would recur, so I would, yeah, I would, do I want to put a for loop here or not? 1 second. Okay, no, I'm probably gonna leave this here for now, and then see if I really need it, but I don't think I do. So this would sort of, be what it would look like. Now, now in this case, what am I trying to do? Just going back to my example, I first want to put a bar at the very first option possible, and I want to loop and continue putting a bar down the line. I want to store all of my sums I get from moving the bar forward, I believe. So now, where do I want to start putting my bar technically? Like, and maybe just phrase it a different way that makes sense with arrays, is that I want to chop off my first element and then chop off the first 2 and chop off the first 3. For index in range, I'd start at 1, length of array. Now is this okay? Yeah, and then I would have to, and then we talked in bars, but I basically do just have to recurse from here. some, so min, I call this recurse min, maybe we'll leave that for now, is equal to recurse array, array from index to the end, and then it'll be k minus 1. That is that. Now I didn't really put a base case here. I forgot. If k is equal to 1, then I just want to sum everything up and send it back. Now,
Yep.
I was thinking maybe there'll be the faster way to do it, but
Just go for the sum.
but I can do this. Yeah. I think there might be some way, but I'm gonna do this for now. For index and range length of the array. Sum plus is equal to so this is the base case, and I'd have to return the sum when there's only one option. So this is okay for now. This maybe could be changed, but I think it's okay for now. For now, going back to my recurse min, I have a sum. This gives me a sum, and now I need like some kind of like local max, local min. And what is there a giant value I should set it at? Well, I could maybe this is I forgot what the import. I guess I can, it would technically be import math up here.
Don't worry about it.
Yeah. So maybe this isn't the best way, but this is my giant value I've compared to. I know that since oh wait, no, it's in my loop. 1 second. Yeah, it's in my loop. But I know that I have to at least go through the for loop at least once, so I'm not worried about returning infinite. I think. So local min is now equal to local min recurse min. Now, is this what I want to happen? Let's see. I think this is what I want to happen. So I put my bar into place, I return the minimum, then I check it for the second place, and I return that minimum, and so on and so forth. And I do want to return the local minimum. Now, this, I want to see if I'd be missing anything from here.
Okay. Think about like before recursing from index to the end, right? From 0 to index, there was a subarray. Okay. When you put a bar, to the left of the bar, there was some subarray, right? Shouldn't that sum of that left-hand subarray also be considered?
Oh, you're totally right. I forgot that when I was doing this. I not only, my recurse min just returns things from the left, but the actual comparison comes from the subarray. So I need to have a subarray from the left and compare that to my subarrays from the right. And it's only one subarray from the left, so I hope there's not like a super quick way. Is my for loop in the right place or not? I guess I don't have I don't have to do it in my for loop. I can I don't have to do it that many times, correct. I could just do it once to have my left subarray up here. And my range would be up to actually no, I do need it in there because that's where I determine where my bar is. So my bar is here. So I have to base it off my bar, which is over here. So
Hold on. One second.
now I don't even know what another way to call it. I'm just going to call it J for now. It'll be
Okay.
0 until index,
Mm-hmm.
and I guess I need a sum here called, we're going to call it left sum is equal to 0, and left
Mm-hmm.
sum plus equals to array J.
Okay. Okay.
Yeah. And then now I have a left sum, I have a
Mm-hmm.
recurse sum, and I have a local min. So I have to check first my max uh, look maybe I shouldn't even call it local min, but I do need what
It's
do I
fine.
even
It's fine. I
yeah
understand. So.
uh, yeah it's left sum and
Mm-hmm.
recurse min.
Mm-hmm.
Um, and then I have my variable. I want to compare my local min to my variable,
Mm-hmm.
and that is how I add everything up. Um, now, am I missing anything?
Yep. So
Okay.
basically, everything looks good so far, right? I just want you to think about whether we need to calculate left sum every time we are at an index, or
Okay.
we can calculate left sum, uh, like,
Yeah,
can we calculate left sum? Yeah.
I would no, because you just have to add the end to it. You know that your left stem starts at the beginning, and you have to
Yep.
keep sliding it over, so to speak. So let me just it would start at 0 here, and
Mm-hmm.
really I think I just have to do 1 second. My left sum starts at 0, and if I call my recursive on my cutting out the 1, then it just adds index. Just see if my index might be one off or one left, one off or anything like that, but it's
Yeah.
simply not. I think this is okay.
Maybe your index is a bit one off. So
It is,
maybe let's add left sum
oh yeah,
at the
you're
very
right.
end.
Yeah,
Yeah.
it's yeah. Oh, that's true. That adding
Let's
it
put
to
it
the
at
end
the
would
very
have.
end.
Yeah, I would
Yeah.
have. Yeah. Oh yeah, you're right. Yeah, adding it to the very end. Um,
Yep. That's it.
yeah, so
That's it.
that is a left sum, and that does make this slightly faster, right? So I don't have to
Yep.
loop over. I want to kind of return to that first. Sorry, at the start of the recurse function, what did I do over here that I didn't like? Oh yeah, on my base case, but I don't think there's a faster way to do a base case really. Um,
I think you can. Okay.
maybe if we
Can
pass
you?
like more variables back, but let me think about that. K is equal to 1. Um, right now what I do is I sum everything up and then I send it back. But can I
Okay. So.
can
Hmm.
I can I maybe I'm thinking like I'm not sure. I'm just thinking like maybe I create something here and then I pass that along. So uh yeah, create something here and I pass that along into the recursive function. A little bit nervous about passing more things. Um, uh, for example, if I start with my left sum, I start making sums from the left. Uh, but I don't think there's a way to do it where I put my comment. Um, let me just think about it from here. 120. So, um, I'm just thinking about this again. So when I pass in, let's only say I have like I passed in this and this is my final answer. Here I don't really see, there's no other way of getting around it and looping it. So I was thinking maybe in the call beforehand, I'd I'd sum up everything from here I get 1 plus 2 plus 15, and then I know if I move my left bar, I slide my left bar over, then I know I'd be passing in, I'd be passing in, like, pass in 10, and then I'd be passing in, um, the 6, and then pass in, etc. I keep like a right moving sum. It looks like you,
Mhm. Yeah.
uh,
Basically, I just wanted to point that out to you. Can you keep a cumulative sum?
y- um, accumulate. What I was thinking, and I'm not sure if this is on the right direction too, but like I cumulative sum.
Right. So
Yeah.
how to
So
tell this? Uh, Instead of splitting the array via indexes in Python, if you could if you could never split the array and inform from which index do we need to calculate to the
oh,
very
so
end.
I pass in just left and right indexes of the array,
Yep.
of the window I kind of want to send in. Uh,
Yeah.
that would require just a little bit of modification, but I can try that as well. Okay, so
Yeah.
but this I
I
write index here. Sorry.
Yeah, one second, one second. So I think we are at the very end of the interview, so it's about 50 minutes, right? So I think you'd be able to solve this given enough time, right? Like with the cumulative sum and like left index and right index. So I think you are good with that part. So I guess we can start with the debrief, if you don't mind.
I go ahead.
Yeah, sure. So for a new grad, I would pass this as a lean hire, right?
You
So uh,
really?
yeah,
You
I
would
would
leave
pass.
me?
Yeah, this is a lean hire. So this is a brute force version of the solution, right? So there's a
Okay.
better version of the solution, which is of complexity n log sum. Okay. If somebody had told me that, then I would give the mid-level recommendation for them. Okay. But for a
Sorry, can
new
you?
grad,
Okay,
yeah,
unlog sum.
yeah, n times log of sum of all numbers
Okay.
in the array.
Okay,
Okay.
thank you.
So
But yeah,
yeah, I would. Okay, okay, you can check this out later. I've just given you the link of
yeah, I can
the
I can
problem.
always fix that myself. But thank you.
You-
Yeah.
Sure. So basically, what you did here is the brute force version of what they showed us in the first step. Okay. So for a brute force kind of a solution, and you are able to like communicate very well. Okay. What is your thought process? Okay. You're able to take hints and suggestions very well and incorporate that in your solution. Okay. All of these things are the stuff that you are looking for in a new grad, right? We don't really
Hmm.
expect new grad to like completely ace the interview with the very best, you know, algorithm or things like that. As long as we are hinting towards them to use something and they are like responding to our hints well and incorporating those hints into the solution, that's a very good signal. Okay.
Okay.
So yeah, I think you did very well. Okay. So even though there could be some minor bugs in here, right? Like maybe range one comma something, it could be plus or minus one index. As I said, we are really not fighting with the compiler, right?
Right.
It could have some bugs, right? But
Okay.
all of us overall, it was a pretty good attempt, like in my opinion, right? Like
I
keep doing this, right?
okay.
Uh, and apply for Google if you want. Like I can probably hit you up with a referral, right? I'll probably share my email ID at the end. You can also do so, and then I can probably give you a referral. This is a pretty decent attempt, in my opinion.
I that's really thank you very much. Like you can probably see I was pretty nervous, and I just want to see who I am and how much I need to practice more before I start approaching interviews. But
Mm.
yeah, yeah, thank you so much. Yeah, I felt like I did not great, but you gave me a lot of hints, and I need all of them. But thank you very
Yep,
much.
yep. Cool, cool. Just a quick FYI, if you think that the Google interview was hella easy, trust me, you would have missed something. That's what I felt, right? Most of my
Oh,
interviewers and like colleagues tell me this. Like if the interviewer thinks they did very well, then probably you might have missed something. But if you think you have not done well, usually it indicates that you have reached far into the solution. right?
I'll keep that in mind. Yeah, thank you very much.
No
Um,
worries. No worries.
yeah, this
Yeah.
is wow. I learned so much though. Like I'm so thankful for you for doing this. This is really good.
Yeah, no worries. Like, I hope you, like, yeah, the fact that you learned some new technique, right? A new way of thinking. That's what I want to convey in interviews like this. As long as you did that, I'm so happy. Like, good luck to you.
Uh, yeah, thank you. Is there one more question? Is there like a theme for this kind of problem? I if I search for recursion, I won't get this question. But is there like a theme so I can practice more things along this line as well?
Yeah. So the theme for the optimal solution, optimal version of solving this problem is, can you binary search the answer, right?
Binary
Say
search.
for example,
Okay.
yeah. Say for example, the output for the first example is 4, right? Okay. That means that the maximum subarray, I mean, the minimum subarray sum achievable is 4. Okay. Can the
Okay.
minimum subarray sum achievable be 5? Right.
I
So,
okay.
so,
I see.
so yeah, take the answer range, okay, from the minimum answer, like from 0 till the sum of all the numbers, right? That will be the possible value for the answer, right? For each of
Mm-hmm.
those answers, right? The each of those answers cannot possibly be the minimum, okay? So it can be the minimum up till some point, beyond which it cannot be the minimum, right? So your candidate answer from 0 to the sum, right,
Zero to some.
will
Yep.
be will be possible, and in some point it will be impossible, right? So the whole goal is to binary search on that answer space.
Wow. Binary searching by sum is definitely, yeah, have not seen that.
Yeah,
Yeah, that's super interesting. I was doing binary search the other day, but I only use binary search if I have sorted arrays, and that's my trigger to try to do them. But searching it by this is yeah, that's something I haven't seen before. I will have to say that as well. Thank you.
yeah. Check that link out. There they do the binary search on the answer, and yeah, expect these kind of questions on your Google onsite, I think.
Yeah,
But yeah,
that's tough, but looks practice enough, and we can try. Yeah.
yeah, you'll be able to get it, dude. Like, don't worry.
Uh, Thank you very much. Um,
No worries, no
I,
worries. Yeah.
I I'm very, thank you. Yeah. No what to say.
So, okay. Then I guess you can end the interview. If you need any more help or info from me, feel free to ask. I'll probably share my email ID.
Okay.
Cool then. See you.
Uh,
Good luck.
yeah. Thank you. Have a nice day. Have a nice night wherever you are. Um, and thank you.
Thank you. Bye.
Okay. Goodbye.